Hello everyone, thanks for tuning in. And this is John, project officer working in speech, music, and vision lab. The reason I'm doing this recording because I wanted all of you to inspire. Uh, inspire. I mean, first of all, I wanted to give you brief background about the project we are part of and the grand vision behind this project. And I'll I'll talk about a couple of use cases and the technology behind and how the models have to be trained and why it is important to gather clean data and in the middle I'll try to explain about the importance of each and every one of you to be part of this project. By the time I finish 30 minutes of the, 30 minutes of this recording, hope I will make you get inspired to be part of this project. I hope you will pay attention closely and once you have time and if you want to be part of this project after listening to this recording, please give your details in the form will be attached in the description below. Then I'll be able to assign you the work and you can take your time and do the work that is asked of you to do. So I'll also show you how you need to do certain tasks. So first of all, let me get into the project. First I'll talk about NLTM project and I'll briefly explain a couple of use cases just so that you will understand the great vision of this project. And I'll talk about how even before that I'll talk about my lab and I'll talk about model training. Then I'll give you a brief outline of how the data collection is done. Then I'll get into the task at hand, so that is audio verification of Indian languages. And since it is a recorded video, question and answer can't be given, but after listening to this video, if you still have any doubts, feel free to call me. My number is this. Try to call me in daytime. Okay, let me get into this. First of all, NLTM is full form is National Language Technology Mission. So the grand objective of this project is build speech technologies for Indian people in Indian languages. This is a consortium of 23 IITs put together. We are working together to build speech technologies. So this is a project fully funded by central government. If I talk about the speech technologies, first of all I'll try to give you a couple of use cases. One is let's say NPTEL lectures. They are predominantly given in English, right? But that technical education must not be just limited to the people who knows English language, but there are those people in India where they want to grasp things. If they can grasp things in their own mother tongue, it can even reach to them in a deeper level. So we wanted to create a technology where they can actually listen to the English lectures, translated English lectures, not entirely, but keeping the domain terms as it is, and translating whatever that is needed for them to understand, something like English. So that means partly Hindi and partly English. So only you keep the domain terms of a particular language in its own form, and add translated rest of it is translated into Hindi. So for that we need to build bilingual models. So if you can build such a technology, so the technical dissemination of NPTEL lectures can be made possible in all the official Indian languages. That is one goal. And second one would be, let's say, PM Modi. He gives a Man Ki Baat in Hindi, right? But if his message must be live translated into all the official Indian languages, isn't it good? Right? For that to happen, you need to have speech technologies. Third one is voice search. Let's say I'm a blind man. If I have to order something, or let's say I'm an illiterate person, if I have to search my crop rates just by voice search, then we need to create speech technologies. Fourth one would be, let's say I'm a doctor from Tamil Nadu who goes to North India. If I don't know what my patient is saying, how will I be able to prescribe good medicine? How will I be able to diagnose properly and help him out? So for that, you need to have a system in place where you can understand the other person. So for all the above things to work out, you need to have 3 technologies in pipeline. First one is ASR, second one is machine translation, third one is TTS. ASR full form, automatic speech recognition. MT is machine translation. Third one is text to speech. Let's say I'll again take Prime Minister Modi. He speaks Hindi. That's a speech, that's an audio, right? So once this Hindi speech is given to ASR module, what it will do is it will transcribe Hindi transcription. Okay. Then the Hindi transcription will be given to machine translation. What this machine translation will do is it will translate the Hindi transcript into the target language. Let the target language be Tamil. Then what you will get out of machine translation module as a Tamil transcript. Once the Tamil transcript is ready, you give that to TTS module. So you will get you give Tamil text and you will get Tamil speech. So you may not be able to hear Prime Minister Modi's voice, but whatever the model that has been trained, whatever the TTS module that has been trained, maybe female or male, then you will hear that voice. Anyway, so I don't have the time to pinpoint each and every 23 consortium members. If you really want to know who are the 23 consortium members, Professor Hema, she explained on this website. You can go ahead and watch. So, but for the time's sake, what I'll try to touch on the key consortium members. One is Professor Hema. She is the principal investigator of this project, and Professor Umesh from electrical department. Okay, Professor Hema, she handles dedicatively on TTS modules, and Professor Umesh, he works dedicatively on training ASR models. And when it comes to machine translation, IIIT Hyderabad works on it. So as far as I know, around 9 languages, I'm talking about ASR, around 9 languages, 3,000 hours of speech recordings have been collected and annotated, and the models have been built on those languages. So with this, if somebody speaks that language, we will be able to accurately predict the transcript of that whatever the person is speaking. If we can build this ASR models for all the official languages, then it's going to be a great thing. And coming to machine translation, I think around 10 to 12 languages machine translation is done. Coming to TTS, we built TTS models for at least 14 languages, and 10 more languages we wanted to build. 10 more languages we want to scale it up. Anyway, so as I said, ASR, Professor Umesh from electrical department IIT Madras, and machine translation IIIT Hyderabad. And coming to TTS, there is 2 people are working on this. One is Professor Hema ma'am, Speech, Music and Vision Lab, Department of Computer Science, IIT Madras. And second one is AFR Bharat. As far as I know, they have been working on entire range of speech technologies, but Professor Hema ma'am, she is dedicatively been working on TTS. And there are other consortium members I did not mention. If you have time, just go back to that website I have showed you, and then you can listen to it on your own. Okay, I'll talk about speech tech, my lab, Speech, Music and Vision Lab. So the objective of this objective or the vision of this lab is train TTS models for all official languages. For all Indian official languages. Okay. How many languages we have? We have 22 Indian languages, plus we are building one Rajasthani plus and English for all the accents, for all English accents, and for both genders, male and female. And the second one is we wanted to collect gold standard data and then open source it for the world to use it, for the speech technologists to use it. And moreover, we wanted to build people around speech technologies. We wanted to inspire them to be part of this project, and also in a way to to make this ecosystem thrive, we need people who wants to dedicate their time and effort in creating these technologies. And once the technologies are built, then there comes the big the end product. End product is create products and services for Indian people by involving startups. Create products and services in agriculture domain, in transportation, in schools, in education, and in hospitals. It's actually a very big vision, so we need a lot of people support in this endeavor. So I don't think we can do this alone, so that's why through this video we are trying to reach out, at least as a first step. Anyway, now I talked about TTS models. So I'll try to explain how model training has to be done. Then I'll try to link with why data collection is important. Then I'll get into what are the tasks at hand. I'll screen share it and show you how things needs to be done. So first of all, TTS means text to speech, right? So you will give a text as an input, and speech must come out as an output. So for that you need to train model, right? If that has to happen, you need to have a broader understanding of three technology. Three fields. One is signal processing. Second one is natural language processing. Third one is machine learning and data learning concepts. So what we do here is we have a text. Text will be like, we have around some 10,000 sentences, and uh, so we collect this text from various domains. The reason we collect this text from various domains because we wanted to cover each and every sound available in that particular language to be covered in these sentences, and the frequency of the phone coverage is also rich enough so that you will have when we are training the models, you will have the enough context. I mean, particular sound will be differing based on the context within which the particular sentence is uttered by any speaker. So because of that, we wanted to collect, I mean, we carefully collected text from various domains, and we picked each and every sentence based on a criteria. So I don't have time to dig deeper into the criteria we used, and so once we select the sentences and we make sure, so we will identify people of that language, so we call them language experts. So we give, let's say I wanted to create a TTS model for Telugu language. What I will do, I will once we collect the text, I will give the text to this language expert. What he is expected to do is he has to go through each and every sentence carefully and make sure that each and every sentence is following, I mean, will be having the punctuation. Second one is no, there is no profanity, and no sentence containing any religious or misogynistic comments, whatever. And we make sure that if there is if there is any extra numbers or special characters or ambiguous, I mean the characters which are ambiguous to speak, then we remove them, or we replace them with the corresponding text. That is one thing. And also each and every sentence will be of different type, right? One is, so sentences, I mean declarative sentences must end with comma, and interrogative tone or interrogative sentences, they must end with question mark, and exclamatory sentences, they must end with exclamatory mark. Once this language experts, they take their time and they read through 10,000 sentences and they correct it, modify it in such a way that so once the clean text is done, clean text is ready, what we do is we identify a professional voice artist of that language. We will identify them, so we will give this text for them. They will sit in a studio, and then they carefully record each and every sentence. Once the text and the wave is ready, what we do is we do something called audio verification. Why audio verification is necessary? Because one, I will explain what happens within a model training. You have the text, you have the audio, so text is nothing but a sentence. Sentence is a combination of words. I mean, what are the sub-word units? The sub-word units are syllables, and phones, right? So we divide the text. So we built something called unified parser. So it will divide the text into the subword units, and then it will keep it that way. And then what we do here is, by using signal processing techniques and and machine learning, signal processing techniques, what we will do, we will identify signal processing and classical machine learning techniques. We will identify the duration, we will predict it properly. Once we identify the durations and we will try to find out MFCCs, Mel frequency capsular coefficients. These are nothing but sub speech units, I would say. So once you have these sub speech units and their corresponding durations and the sub word units, what you will do, you will try to map, model will try to map between the speech units and the text units. So let's say a particular sound is associated with a particular character or particular phone, then it will map it. So it will learn based on the context within which a particular sentence is uttered. So this mapping will happen. So in the process, let's say the text and the audio is not matching. So in the text is something is there, in the audio it is something is there. If you try to do a model, what happens is the units of speech units will be wrongly mapped to the text units. So because of that, model will learn wrongly. If you give some unknown text, it will synthesize something, it might synthesize something gibberish, you might not even know. That is why it is very important to do a task called audio verification before we even train models. So here is the work that we need help with. So what we do here in this task is, you have the text and you have the audios, and we would ask you to listen to this audio line by line, audio by audio, and then make sure that this audio, whatever that you are listening to is there in the text. There is a possibility you might give a pause where the full stop is not there, so you have to add it. So short pause means it's a comma, and there is a possibility for English language, no matter how proficient you are and how much professional voice artist you can be, there is a possibility you might fill in the gaps. There is an empirical number, around 4% of, out of 100 words you uttered or 100 sentences you uttered, maybe within some four sentences you might fill in the gaps with some extraneous characters. You might fill in or omit certain words, something like prepositions, or, yin, da, ye, yan. It's for English, but for other languages I don't know this empirical number. So what I would ask you to do is, I would ask you to listen to this audio and the corresponding text and make sure that audio and text are matching. So we have 3 criteria: verification status, we have 3 drop down buttons. What you have to do, if audio and the text are completely matching even to the point of punctuation, then that's called pass. Second one is, let's say whatever the audio and the text are not matching, I mean at least a word must be added or a character must be added. So what you need to, maybe a full stop needs to be added at certain point. What you need to do, you keep it as a fail and edit at the same place. And third one is re-record. That means whatever the audio that you were listening to, one, it is gibberish like a old tape record, then you ask them to re-record it, or otherwise non-uniform syllable rate. That means a speed with which you record a sentence. Let's say if I have to read a particular sentence, automatic speech recognition, machine translation, text to speech. So it's like I'm reading everything uniformly, but in a non-uniform pace, let's say half of the sentence you speak in a uniform manner, half of the sentence you speak in a bit faster way. If that happens, so you need to send it for re-recording. So we wanted to maintain that pace. Okay, that is one thing. So once you carefully once you make sure that audio and the text are matching, then we will take this for training our models. We will use this data for training our models. So I'll share my screen and show you around. So these are the worksheets. I'll share my screen. First of all, I'll exit out of this. Ask you to, let's say for English, right? Dataset is ready. So we have for each and every language we have 10 hours of lecture, 10 hours of the recordings. So I divided them into 4 parts, not equal parts, unequal parts. Quarter 1 and quarter 2 are equal always, and quarter 3 and quarter 4 are at least 1 or 2 hours lesser than quarter 1 and quarter 2. So here I'll show you how many we have. So 3100. So in quarter 1 and quarter 2 you will have around 3000, and in quarter 3 you will have around 1500, and in quarter 4 you will have around 1200 or 900 or 1000. So what you must do is, so look at this file ID and look at this file ID, and if these two things are matching, then you have to click on that wave and then let it play here.
We all want progress, but if you are on the wrong road, progress means doing an about turn and walking back to the right road.
That means, so each and everything is correctly spoken, and that means it's a pass. Let's say a character must be added. So what you must do, you must put a file and do the changes here itself, right? So that is one thing. And let's say you have a gibberish audio and the syllable rate is not non-uniform, you just put it for re-record. There will be cases where the pronunciation of a particular word is not up to the mark. So what you can do is, uh, you can't change the audio, but you can change the text in accordance with the audio, right? So if the pronunciation of a particular word is wrong, um, you have the flexibility to change the text in line with the audio. That you can do. And there are cases in particular accents, since this is an English language. Assami people, they have a particular accent, and they might tend to speak a particular word in quite uniformly, even if it is a wrong pronunciation, but they tend to speak it in a way that is not up to the mark. So if that is the case, then you can keep it as it is, you don't have to change the text. But if a particular word is spoken entirely wrong, since you can't change the audio, make sure you change the text in line with the whatever that has been spoken. So the end goal is text and the audio should match, and the model should learn correctly. That's all. That is the end goal. So when it comes to English language, that's how it is. When it comes to monolingual languages, something like Assamese or Bengali or Konkani or Malayalam or Sanskrit, so these are the data, the green ones are the data sets are ready. So I'll show you Telugu. So you have a quarter one. You listen to the audio.
కేరళలోని కొట్టయం జిల్లాలో ఉన్న కుమారకోం పక్షుల అభయారణ్యం ప్రకృతి ప్రేమికులకు చాలా ప్రసిద్ధి చెందింది.
Okay, so it's perfectly spoken. But then see, we have a problem here. In Google Sheets, you can't actually type Indian languages. So for English, you can type English as it is because we have an English keyboard. But for Indian languages, you don't have a keyboard for a keyboard support for Google Sheets, right? So to help, I mean, even just to click on this audio, you just have to click on that link and then go back to the other tab and click on here, listen to it, and come back to this. So I mean, to come out of this, to help all of you, we built an app. So what it will do, it will all the data will be taken from the sheets, and all the data can be accessible on the mobile app. So you have on top portion, you will have a file ID. In the middle, you will have the text, and in down you will have an audio button to play. You can just play on that audio button, so you don't have to click anywhere. It will be there on the screen, everything, and it won't even take more than a second. It will directly load instantly. Then let's say and you have an option to change pass, fail, and re-record. So I will give you demonstration of that app, or Harish might give you. He's the one who made that app. He's a student of computer science, so it's better he does the demonstration. So in meantime, so that app will have so let's say you want to edit a particular sentence, what you have to do, you have to choose on that app fail, and there is an option to edit. You can click on that edit button. So it has a keyboard support, Google keyboard support. You can select whatever the language you want to select. Let's say for Telugu language you will select a Telugu. You type in English and it will transliterate into Telugu word, and you keep it, so you save it there. So whatever the saves you made on that app, it will be reflected in the sheets. So you don't have to worry. You don't even have to open a computer. Even with your mobile phone you will be able to access the data and do this work. And to go to the next one, you have to click on the next button and it will go there, and you can keep editing. So I mean, to make your job easy, and we even selected very good interesting lines from your languages. So hope you will have a good time while you are doing this work. And so here I have even given this entire quarter audio files. You can just click on that and download that data on your local system and play in your own VLC media player. If you don't want to work with your mobile phone, you can work on the system as well. So I think whatever I wanted to share with you, I think I shared everything. And coming to the money part, since this is a central government fully funded project, we will pay you duly. For English language, for 10 hours, based on our observation, 10 hours will take 20 hours. So for every hour we are going to pay so 300 rupees. So 20 into 300, 6,000. Yes. So for English language we'll pay you 6,000. For Indian languages we'll pay you 8,000, because it is a bit hard to type in an Indian language correctly. So that's it from my side. If you still have any questions, you can feel free to contact me. If you think that you have time and you wanted to contribute to this NLTM project, feel free to give your details in the form mentioned in the description below. Then datasets are ready, even the app is also ready, and I just want your commitment, your statement of commitment. If you are willing to work with us and give your details, fill the form and give your details, and I'll send you the work right away. So I don't have the work for all of you, but whatever the data sets ready as of now yet, for Telugu, Tamil, Sanskrit, Malayalam, Konkani, Kannada, Bengali and Assamese I have right now, and one data set of English is also ready. And so that's it from my side today. So if you still have any questions, and you can feel free to contact me, and hope to work with you. And also I'll try to attach the recorded video of that app, so that you will have a better first hand, or at least a virtual understanding of how the app works. Then it will make your job easy. Yeah, that's it from my side. Have a good day.